All right, so the mole is a counting number, just like the dozen is a counting number. And in this particular instance, the mole itself is a value that's associated with, it's like one of moles equal to one big thing. And we'll talk about that in a minute, but let's talk like about something that you might be familiar with. A dozen, right? A dozen is equal to 12. So if I have a dozen cookies, you might say that, or if I have a dozen cookies, you might say that you have a dozen or 12 cookies, right? Which is barely a snack, especially if they're Oreos. A dozen crackers would be 12 crackers. And a dozen chips would be 12 chips. And I guess, right. Now, another counting number that you may or may not be familiar with is something that we call a gross. So if I had one gross of cookies, I would have a dozen, which is 144 cookies, which is a serving. And if I had a gross of crackers, I would have 144 crackers, which I'm just not a big fan of crackers. Unless there's cheese. There's cheese on a cracker. And then if I had a gross of chips, which at my house somehow turned into chaps. I don't know how that happened, past the chaps. But we would have 144 chips, which is closer to an actual serving of chips, because 12 is, it's not a real serving of chips. Yeah, Oreo is a bold-faced liar when they're like, here, you should have 2 Oreos in one serving. They're lying to you. Anywho, if a dozen is a counting number, and a gross is a counting number, and a mole is a counting number, let's take a pause and talk for a second about how to use these. So you may recall dimensional analysis, where we did like 6 dozen and we were looking for the number of cookies. So you might do something like 6 dozen cookies. Put that over 1. You might set up a conversion factor.
Can't you just do 6 dozen?
Just which sometimes we label as CF, and you would say something like dozen cookies equals cookies. Oops, I did that in the wrong color. Gosh, that is not my best work. There we go. And you might recall that 12 cookies was equal to 1 dozen cookies. And you might say that we would set this up so that dozen goes on the bottom so it cancels out. And cookies goes on the top, so that's what we're trying to find. And then you'd fill in the value, so 12 cookies is the same as 1 dozen. And then you'd multiply straight across, and 6 times 2 is 12. Carry the 1. 72 cookies are in 6 dozen. And yes, I hear you when you say, couldn't you just multiply straight, just multiply it? The answer to that question is sure, but I'm trying to prove a point for the math that we're going to do in class today. So, here we go. So what's a mole? And I'd like to take a minute to remind you that 1 dozen, which is that counting number, was equal to 12 anythings. So you could have like a dozen eggs, a dozen cookies, a dozen bowling balls, a dozen golf balls, a dozen desks, a dozen friends, a dozen siblings, which would sound awful. Okay, now, but the mole has a specific value, which is 6.02 times 10 to the 23rd. And nobody actually writes that out, but like I'm going to because it's 602 with 21 zeros after it. 3, 6, 9, 12, 15, 18, 21. That's a giant number. It is stupidly large and difficult for us to wrap our heads around. But 602 with 21 zeros after it is huge. So 1 mole of anything is equal to 602 with like 21 zeros after it of that anything. But usually in our case, we're going to be talking about atoms. So 1 mole of carbon would be equal to 6.02 times 10 to the 23rd atoms of carbon. And 1 mole of silicon would be equal to 6.02 times 10 to the 23rd atoms of silicon. And 1 mole of nitrogen, you guessed it, is going to be equal to 6.02 times 10 to the 23rd atoms of nitrogen. Yeah? No? So far, so good? So hopefully you're seeing a pattern that 1 mole of any element on the periodic table is going to be equal to 6.02 times 10 to the 23rd atoms of that thing. Now this number in science has got its own special name. 6.02 times 10 to the 23rd is called Avogadro's number. And it's called Avogadro's number because Avogadro was a scientist or alchemist, I forget which one of the two, basically the same. And he made the observation that said that if you have a balloon that is filled with 1 liter of helium and a balloon that is filled with 1 liter of, let's say, chlorine gas, which are 2 very different elements, he said that the number of particles inside that of each 1 liter balloon would be the same. People thought he was crazy talk, but turns out he was right. So Avogadro said that in any volume of gas that is the same as a different volume of gas, the number of particles would be the same. I'm going to try to write that a lot neater. So Avogadro said that in 1 liter of gas, the number of particles will be the same in 1 liter of a different gas. Okay? So that's basically what Avogadro said. And he didn't count atoms or particles. That was his thought or his theory. And people kind of thought that he didn't know what he's talking about. But then what ended up happening is he ended up being right, but he passed away before he was able to be told that he was right. So we honor him with the number 6.02 times 10 to the 23rd atoms.
What's an alchemist?
The question was, what is an alchemist? The answer to that question is, an alchemist was an individual who thought they could make something good out of useless material. For example, they would take something like a chunk of iron and say that they could turn it into gold.
No, I thought it was like something magic or something.
But, he said he thought it was something to do with magic, and actually a lot of people thought that they were doing magic.
Wrong.
They were not.
Yeah.
They were doing science. Or sort of heretics, I guess, of their time. Now, so here's what we're going to do with it. We are going to practice the math associated with the mole. Now, you are going to be asked in this problem to convert 6.47 times 10 to the 23rd atoms of copper into moles of copper. So I'm going to do what I've always done in the past, is I'm going to take my given, which is 6.47 times 10 to the 23rd atoms of copper. Actually, if I'm smart about this, I'm going to move this up a second here. You're good. Don't erase yours. So 6.47 times 10 to the 23rd atoms of copper, and put it over 1. And then I'm going to set up a conversion factor because I really need to figure that out. So I need to know the relationship between atoms, copper, and moles of copper. And if you recall from the slide above, we said that 1 mole of anything was equal to 6.02 times 10 to the 23 atoms of anything. What is going on? Cool. All right, now, so I'm going to set this up so I can cancel out what I have in terms of units. So atoms of copper is going to go on the bottom. Moles of copper is going to go on the top. I'm going to use my values in my conversion factor, where 1 mole is equal to 6.02 times 10 to the 23rd atoms of copper, which is Cu, not C. And then I'm going to calculate my answer, and this is why I made sure everybody had their handy-dandy calculator. So please get out your calculator and calculate the answer. And while you're doing that, I will calculate my answer, and we will compare. So my guess is you got either one of these two answers. Yes? And if you got one of these two answers, it means you plugged it into your calculator correct, or you plugged it into your calculator incorrect. My guess is that if you got 1.074750831 times 10 to the 46, you plugged it into your calculator incorrect, but I believe that that's probably the number that most of you got.
Don't you have to do like that thing where you press E or something?
So to refresh your memory, we are going to talk briefly about how to put these numbers in your calculator. Okay? So please play along with me. So clear out your calculator and let's get so we can get the right answer. So step number 1, you would type 6.47 and your calculator screen would be 6.47. Step number 2, if you have a calculator that looks like this, you would type second and you would type x minus 1. And your calculator would give out 6.47e. If you have a graphing calculator, you would type second, and it would be the comma, which is the number above the 7, and you would have 6.47e. And then for step 3, you would type in 23, and your calculator would give you 6.47 E23. Then for step 4, you would hit divided by, and your calculator would give you 6.47 E23 slash. For step 5, you would type 6.02, and your calculator would read 6.47 E23 divided by 6.02. You would then type second x to the minus 1, or second comma, and your calculator would read 6.47 E23 divided by 6.02 E. You would then type 23, and your calculator would say 6.47 E23 slash 6.02 E23. You would then hit the equals or the enter button, and your calculator would write 1.074750,831. Hopefully. Please take a moment and plug that into your calculator and make sure that you can get the correct answer. And then also let me see it, because I want to come around and check to make sure that we're doing things okay. Okay, so the last thing we need to talk about in terms of this problem is significant figures. So what I'm going to do is I'm going to assess significant figures. I'm going to draw that arrow coming in here, and I'm going to count 1, 2, 3. So this has 3 sig figs. So that means my answer has to have 3 sig figs. So 1, 2, 3. I draw a line, which then tells me that that's 4 cannot round that 7 up. So my final answer is going to be 1.07, and that's going to be moles of copper. Huzzah. Woo. Cool. Let's try another one. Give it the old GHS try here. So in this case, we are going to convert 4.7 moles of strontium to atoms of strontium. So let's set this up. I'm going to take the 4.7 moles of strontium, put it over 1. I'm going to set up my conversion factor. So I'm going to be looking at the relationship between moles of strontium and atoms of strontium. Okay. And I know that based on what we just talked about, in 1 mole of anything, there should be 6.02 times 10 to the 23rd atoms of anything, which in this case happens to be strontium. So now I'm going to set my problem up so my units cancel out. So I'm going to have moles of strontium on the bottom and atoms of strontium on the top, which I realize I should spread that out a little bit. Okay. And then I'm going to fill in the values. So 6.02 times 10 to the 23rd atoms of strontium is equal to 1 mole of strontium. And now we're just going to calculate. So grab your calculator, take 4.7 times 6.02 E23. Let's see what we get. Remember to assess significant figures.
Did I do it right? It gave me times 10 to the 24th column, but I put the E. Oh, I did.
Hopefully when you plug this in, you got 2.8 times 10, or 2.8294 times 10 to the 24. You saw that the original number in the problem had two significant figures, so you needed to round it to have two significant figures, so you ended up with 2.8 times 10 to the 24 atoms of strontium. Questions? How would, yes? So the 25th? If it says to the 25th, I am betting that you put 6.02, the multiplication symbol, E23. Is that what you did? Okay, so let's take a look. So, yes, okay, so E means times 10. So you took it times 10 times 10. That's what that's right. So you don't move the times.
She's getting. I already do the just name. Older date.
Yeah. Oh, wait, no. Yes, but this was just doing
That's why he is here.
So we didn't write down. Because in the problem, there's just 4.7. In the problem here is 76.47 times 10 to the 23. So you added that. Okay. Excellent stuff. All right, so let's talk about another way that we do moles. So here we go. When we go into lab, though, there is no device that allows you to actually measure out a number of atoms or measure out moles. We just don't have a device that does that. So what we have to understand is that we have to figure out a way or use a different relationship that allows us to understand the mass of something, which is what makes our lives a little bit easier. So in this example right here, you might recall from the last unit that this is the average atomic mass. Okay? You might recall that's the average atomic mass from last unit. What I can tell you, though, is that that number on the periodic table is equal to 1 mole of that element. So if I had wanted 1 mole of iron, you would go back and measure out 55.85 grams of iron on the balance. If I wanted 1 mole of zinc, you would go to your periodic table, locate zinc, and you would identify zinc to have a mass of an average atomic mass of 65.39 grams of zinc. And if I wanted 1 mole of lithium, you would go to your periodic table. You would locate lithium. You would identify the mass of lithium to be something like 6.94 grams of lithium. And what I'm trying to make the point here is that different atoms or different elements have different average atomic masses, but they all have the same value in terms of a mole. Now, to go one step further, if I measured out 55.85 grams of iron, and I told you that was 1 mole of iron, how many atoms of iron would I have? Anybody?
Isn't it the same?
It would be the same as the number from before, which would be 6.02 times 10 to the 23rd atoms of iron. Or if I had 1 mole of zinc, which is 65.39 grams of zinc, I would have 6.02 times 10 to the 23rd atoms of zinc. How many atoms of lithium would I have?
6.02.
Yeah, 6.02 times 10 to the 23rd atoms of zinc. Now, or lithium. But what if, as long as we're talking here, what if I wanted 2 moles of carbon? How many grams of carbon would that be? If I wanted 2 moles of carbon, how many grams of carbon would that be? Well, I would go to my periodic table and start there. And I'd probably ask myself, how many grams are in 1 mole of carbon? And you would say to yourself,
12.
12.01. But if I wanted 2 moles,
Oh, wait. 24.06.
yeah, it'd be 24.02 grams of carbon. So how many atoms of carbon would that be? Well, that would be 1.204 times 10 to the 23rd atoms of carbon. So double 6.02. Does that make sense?
Is it 6.02, 12.04?
Yeah.
Yeah, but it'd be times 10 to, sorry, I miswrote. This should be the 24.
Wait, then why is it that one? Oh, I mean, that one's, why isn't it 12? Why is it 1.
Because technically 6.02 times 2, you're right, would
Oh,
be
because
12.
it can't
But,
be over 10. Yeah.
okay. Cool. All right, now, so let's use our new found understanding of stuff. So here I'm going to convert 54.27 grams of titanium into moles of titanium. So I'm going to do like I've done in the past, which is 54.27 grams of titanium. Put it over 1. And then I'm going to set up my conversion factor, which is asking the question, grams of titanium equal to moles of titanium. Well, if I wanted the relationship between 1 mole of titanium and grams of titanium, I would go to my periodic table and I would locate titanium, which happens to be element number 22 on the periodic table, and I would find that would have a value of 47.88 grams. So I'm going to set this up so grams of titanium cancels out, and moles of titanium is what I'm trying to solve for. And so I'm going to take my relationship, which is 1 mole of titanium is over 47.88 grams of titanium, plug it into my calculator. So 54.27 divided by 47.88. And the calculator gives me a value of 1.133458647. We have to assess significant figures. So I'm going to take this arrow, draw it to there, and count 1, 2, 3, 4. So I have 4 sig figs here. So I'm going to do the same thing to my answer. 1, 2, 3, 4. Draw a line. That 4 cannot round the 3 up. So my value is going to be 1.133 moles of titanium. Woo! Questions? All right, let's do one more, and then we'll shut her down for the day. You do this one. You do this one. You do this one. Ready, set, convert moles. All right, for those of you that are playing along, we found that the relationship between moles of carbon and mass of carbon, or grams of carbon, was 1 mole of carbon is equal to 12.01 grams of carbon. So I set up my conversion factor so that moles of carbon was on the bottom so that it would cancel out. Got mass of carbon on the top, multiplied straight across, got 13.5713. I identified that this problem started with 3 significant figures. So as a result of that, we needed to have our answer with 3 significant figures. So I counted 1, 2, 3. That's 7. Definitely rounds the 5 up to a 6. And I got 13.6 grams of carbon. Questions? All right. So that leaves us with no homework for today.